everyone, welcome to the session. In this particular video, we will talk about a very interesting randomized data structure. This is a part which is a portion of advanced data structure algorithms. And I know that many of you all have heard this term for the very first time, which is called as skip list. Before talking about this data structure in very much detail, I want to talk about what do we mean by randomized data structure. See, for every data structure, whatsoever we have heard so far, whether we started with the arrays, then we have a great talk about linked list, then we heard about hashing and we did a great detailing over there as well. After that, we have trees, we have graphs, so many different kinds of data structures that we have. But for the very first time, I'm coming up with this term called as randomized data structure. What is the meaning of that? The simple meaning is that in this data structure, I'm trying to do something on a random basis, on a probabilistic basis, and with the help of which we are trying to do the task, right? What task we are trying to do? Let's wait for a moment and you will be able to get a clear-cut idea about that. So let's get started with the skip list data structure here. Here, if you will observe, when I'm talking about skip list, there are a few things that we will try to understand in this session. First of all, we will try to see that, first of all, what's the motivation behind these kind of data structures? Why is that so? Secondly, why the skip list is required actually? Thirdly, how we can build any skip list? Fourth thing that we will try to understand is, given a skip list, okay, we will be able to build that. How we can do any searching operation inside that, right? And after that, we will talk about insertion and deletion inside the skip list data structure. So let's get started. First of all, what's the motivation behind this data structure? So we have seen so many great data structures like linked list, like arrays, like binary search trees, right? Which can give a average case performance on random inputs. But when we talk about for particular inputs, it can give us a bad performance. For example, in BSTs, when we will be having a lot of skewness, at that point of time, if you will remember, we will be able to get an unbalanced binary search tree. At that point of time, I can say that the performance is pretty much bad. So what we are trying to do is that instead of we will try to randomize the inputs, why not to randomize the data structure? That is the overall analogy behind the researchers who made this work to be successful. So what we are trying to do here is that we are trying to majorly work on top of a sorted linked list here. If you remember, when I talked about the linked list data structure in one of my module, which I hope that everyone until so far have heard that and have did a great work over that as well. So you have seen that I talk about that random access is not possible there, right? Randomly, I can't go to any one element there and I can't able to access that data in case of a linked list. In case of arrays, it would be clearly possible. So specifically talking about searching complexity, in case of a binary search, I am able to optimize that from big O of n to big O of log n. And it was quite easy for me, right? Because of the random access property. But when I move towards the linked list, I told you that random access is somehow not possible here. So we have the only one option which is left, that is to traverse each and every node to reach to the element which you want to search for. That's where this concept of skip list was designed. It's a generalization of, I would say, sorted linked list, and it's really easy to implement as well. It is invented around 1990 by Bill, and it maintains a dynamic set of n elements. Here you will observe at the very end of the session that when we are talking about the searching in a skip list or insertion or deletion, the time complexity is something which is big O of log of n. How is that so? We'll try to get the intuition behind that. See, in order to understand this particular concept in very much detailing, if you will try to understand, then a lot of probabilistic based concepts are important. That's why I used to say that maths play a very important role whenever you want to get a greater intuition or idea behind the data structure and algorithms, or specifically talking about data science as well, right? So here in this specific session, probability plays a major role. I will not go towards the derivation in very much detail because I don't want to give you proofs here. I'm not talking about those proofs. If you want, we can make a separate session for that. But what is the agenda for today's session is that because maximum students don't know the idea behind the skip list. So I want to give you the intuition behind the skip list, that yes, there exists something above than the linked list, which basically helps in terms of doing a searching cost as big O of log of n. And if suppose someone is asking to you in an interview that do you know any data structure which can give you big O of log of n time complexity, but in case of a linked list, then this is the data structure which they are talking about. So it's very important for you to understand the concept related to skip list. At least I'm talking about intuition here. So let's see. First of all, why skip list? I gave you the intuition that skip list usually is the generalization of a sorted linked list. Why it is required? Because linked list doesn't support binary search. Even though I am having a linked list which is as a whole in a sorted fashion, doing everything in a perfectly well manner, but if I want to search any node inside that particular list, I have to traverse all the way along. I don't have any other option. That's the simple problem that I was facing in case of a linked list. So what skip list did is that skip list says, I will provide you the solution. I have one intuition behind solving this problem, with the help of which we will be able to get the search space time complexity as big O of log of n. How is that so? I know you all are curious, so let's get started. So how basically this skip list is created? Usually consider that we will be having a what I would say normal linked list that we have. So I'll try to create one normal linked list. Again, whenever I'm talking about a concept of skip list, always remember that I'm saying that it's an advancement over the linked list. So here the major concept of binary search, which was not possible in case of a linked list, is possible in case of a skip list. So when I am saying binary search, that concept that we already have understood in our array data structure, that the data should be in a sorted fashion, is also applicable here. So the data inside the nodes, I would say, will be in a sorted manner. That is again, I would say, the most important thing to understand. Data inside the nodes should be in a sorted fashion. Here, what I am saying here, for example, here I am having the node. So let me try to create the node for a linked list first. So this is node 1, this is node 2, this is node 3, this is node 4, this is node 5, this is node 6. Okay. So here pointers are there. So we all know that node contains two parts. One is the data and other is the next pointer. So whenever we are talking about node contains two parts, data and the next pointer. So here, when I am talking about a skip list, it will always have a sorted data. So for example, 2, 4, 6, 8, 12 and 15. And suppose this is the address of the node 100, it is 200, it is 400, it is 500, it is 700 and suppose it is 900. So what we are trying to do here is that we are trying to point to the next node. So here if you will observe, it is 200, it is 400, it is 500, it is 700, it is 900 and it is something which is equals to none. Now this data is in a sorted fashion and this is something which I can say is a L0 layer, where I'll try to store the pointer of the first node which is pointing to here. This is something which we called as a sentinel node in case of a skip list. Now, at L0 layer, you will be having a normal sorted linked list only. Nothing big that we already have understood, right? What is a linked list? We all know. So at the L0 layer, I am taking a normal sorted linked list only, correct? Now what I am trying to do here is that at each and every time, I'll try to take the nodes. So what I will do, again I'll start from 100. So this is taking the pointer only. Now what I am trying to do is that I am trying to extend the layers at the topmost position in such a way that for every node I will try to flip the coin, and that is where the randomization is coming into picture. So what is randomization in this data structure? Now you will try to understand. So here I am talking about the randomization. So what we are trying to do here is that we are saying that for every node I will flip a coin. I will flip a coin. And coin being unbiased, there is an equal probability of the coin, 1/2 probability of coming as head. Can I say? And 1/2 is the probability of coming as tail, right? Now if I am saying that if head will come, I will extend the node to upper layer. I will extend the node to upper layer. And if tail will come, there will be no extension. There will be no extension of the nodes to the upper layer. Now if you will see, the probability of getting the head or the tail, it's something, can I say, is a random task. So there is equal probability. Yeah, that would be unbiased only. Your way of doing that should be unbiased. It should not be like that you are having a biased outcome of getting always head or always tail. Now, what we are trying to do here and what's the intention of doing that, please bear with me for a few more minutes, you will get a clear-cut idea. Here now, if you will try to observe, for example, here I did the flipping of a coin at the node number 2. I flipped the coin, and after flipping the coin, suppose I will be getting the value as 2. So what I will try to do here is that I'll try to again mention the 100 address, and here I'll extend my node to 200, because now I am taking this data, this particular node, which is 2. Now for this node, for the next upcoming node, again the flipping of coin will happen, and suppose tail is coming up. And because tail is coming up, it will not extend the node to the, suppose it will be called as L1 layer. So we are trying to create the above layers in case of skip list. And here if you will see, what I am saying is that we are trying to flip a coin for every node. And when head is coming up, we are reaching towards we are creating the same node in the upper layer. Otherwise, we are skipping that. And because we are skipping that, that's why it's called as skip list. That's where the name skip list came into picture. I hope that I'm making sense to everyone. So here if you will see, for 4, suppose tail is coming, so there is no creation of a node here. Suppose for 6 node, again I would say head came. If head came, again I am trying to copy the pointer here, which is 500. Now it will not basically taking the value as 200, it should take the value as 500, so that it will directly start pointing to here in case of L1 layer. Again for 8, suppose you flip the coin and you get head. Sorry, you get tail. So at that point of time, when you're getting a tail, there is no extension. And then suppose here you again got the extension. You got again as the head. So here, whichever I am marking as green node, I am saying that head is coming up. And that's where again the extension happens. So when extension happens for this particular node, which is having the address, so this is having the address 400, so here the value should be 400, so that it will start pointing to 400. And here the address for the next node is 700, so here it should contain the address as 700, so that it will start pointing here, right? And maybe this is the last node, because in the next node itself again you are getting the value as tail, and that's where you will not extend your node. So now this particular node will contain the data, which is 2, here it is 6, and here it is 12. Can I say? So basically what is happening is that in a skip list, if you will observe, we skipped 4 here, we skipped 8 here, we skipped 15 here at the upper level. Why? Because here we did something called as randomization. This is how the building of a skip list will be done. So if I will try to show you the image in the presentation as well, if I will try to show you, so here if you will see, what I am saying is that new layer is added on top of the bottom list. Bottom list is something which is the actual linked list that we have. And after that, we are trying to create a new L1 layer. This layer will include any given element from the previous layer, but with the probability P. P probability is the event that which should be unbiased. For example, I talk about flipping a coin, which is an unbiased event, and both is having a probability of 1/2, getting a head as well as getting a tail, right? Now, for every layer, now you can ask me the question that how many number of layers should I create? It simply depends on the number of elements, as the number of layers that you will create in a skip list will be equals to log of n base 2, right? If you are having maybe 10 elements or maybe 16 elements, suppose in total you will be having 16 elements. So what you will try to do, you will try to calculate what is the value of log 16 base 2, right? So it will be 2 to the power 4. So 4 should be the answer. So at that point of time, you need to create L0, L1, L2 and L3 layer. Simply, this is the approach that you have to follow. Now, what I am saying is that starting from L0 layer, when you are trying to create the L1 layer, how will you decide that for which particular node you should create a node, or for which particular node you should skip that? For every node, we are making a random choices to whether we should grow that height for that particular node or not. L0 layer is the only layer which is fully connected layer. Afterwards, if you will observe, somehow, because you are having an unbiased event, both are having a probability of 1/2. So definitely any outcome will come where you're getting a tail as well. So what I'm saying is that you will definitely get the L0 layer as the correct linked list, which is the original linked list, but afterwards you will always get a skipping linked list layers as well, right? So this is the way which I was talking about. So here if you will see, the very first node, which contains only the pointer of the first node in your linked list, is called as sentinel node in the skip list. After that, we will be having the data and the pointer. Data and the pointer. So in this way, 2, 8, 10, 11, 13, 19, 20, 22, 26 and 30. This is the original linked list that I have. Now what we are trying to do here is that we are trying to basically done a randomization here. The event of flipping a coin. If suppose I am getting a probability of 1/2 of head, so I will try to basically, extend the node. I will grow the height, otherwise I'll skip that. For example, for 2, it means that we get an head. For 8, we get a tail. That's why we didn't extend it above. For 10, again we getting a head, we extended. For 11, we get an head, we extended. For 13, we get an head, we extended. For 19, we get a tail, so we skip that. For 20, we get a head, we extend that. For 22, we get a tail, so we skip that. For 26, we got a head, so we extend that. For 30, we get a tail, so we skip that. Now, once L1 layer is finished, what you need to do is that you need to do the same task for L2 layer. Now for L2 layer, you will take the reference from L1. So for L1, you will say you are getting a head, so you will further extend that. After that, you directly jump to this particular 10 node where you will just see the head or tail. Suppose you're getting a tail, so you don't need to extend here. Then you directly see 11 tail, no need to extend here. 13 head, again you need to extend. 20 again, if you will observe, tail, no need to extend. 26 head, again there is a need to extend. So basically for L2 layer, whenever you are trying to create, the only reference that you have is L1. Forget about L0 layer now. For L1 creation, you have seen all the nodes present at L0 layer. But when you are doing for L2, you need to just see the L1 nodes that you have. Similarly, the same thing will happen for L3. So while doing the creation of L3, what will happen is that you will only try to focus on the nodes that you have in L2 layer. So here, for this particular node, so very first sentinel node will always be there. That is for sure. Now for 2, again you're getting a tail. You skip that. For 13, you are getting a head. You get that. For 26, again you are getting a tail. So you skip that. This is how the complete skip list will be there. How many number of layers we should reach? I already talked about log of n base 2. So if you will be having 16 elements, you can go until 4 number of layers. Or if suppose you will be having 15 or 14, so you can take the upper bound of that. So that is the overall way to build a skip list. Now you can ask me one simple question that, okay Priya, this is fine, but how basically this is helping me, to do the search faster? Because as you told me that whenever we are doing a skip list kind of data structure, it is basically used for doing a efficient searching operation in case of a linked list. But here too we are somehow extending the list only, right? So how basically it is helping me in searching operation? Let me talk about that now. For example, I want to search for the key 8. This 8 I want to search for. So now what will happen is that I will always start searching from L3. So in L3, I will directly jump to the node 13. Now I know that the element which I am looking for is 8. Please try to pay attention towards this part of the video. Otherwise, you will not able to get the part which I want to convey with this session. So here if you will observe, suppose I want to look for 8. Now I will always start from the topmost layer. That is the very first thing. So I will start from the L3 layer. Now I know that the element that I am looking for is 8, which is somehow lesser than the value of 13. So at that point of time, I will not move forward. I will go to the lower layer. And I'll check. I will reach to the node number 2. So here if I will observe the value 8 which I am looking for is greater than 2. So I will go further and again I reach towards this 13 node. So as I reach towards a node which is having a value higher than the node which I am looking for, I will go to the lower layer. For example, in this case again, I am getting a value 13 again. So it means that I can't move forward. I have to go towards bottom layer again. So I will go towards L1 layer and again I will see 2 is there, 2 is greater than 8, I will move forward, 10 is there, 10 is greater than 8. So again I will move to the L0 layer, 2 is there, 8 is there. So somehow if you will observe, anyhow I never came across the elements which are greater than 13, that is the very first point. Means I didn't look for 19, 20, 22, 26 and 30. So I am able to skip all these nodes while doing the searching operation. Second thing is that whenever I am encountering any node which is having a value greater than the value which I am looking for, I am going to the lower level node. So final element you will always get maybe at the very end, which is L0 itself. For example, if suppose you are searching for 13, then at L3 layer itself, you will be able to get the node and you can return the final value as true or false. But suppose you are looking for 8, so in worst case scenario, you need to reach to the lower level layer. That's the worst thing which can happen, right? But ultimately, you will be able to skip half of the elements always, right? So here if you will observe, we started from the upper layer. We tried to see that if we are getting an element greater then the element that we are looking for, we go to the lower layer until we reach to the original value. And with the help of this, we will be able to remove, or we will be able to reduce the number of comparisons. Somehow we will be able to skip the maximum number of nodes while doing a comparison. And that is the overall funda behind the building of the skip list. And that is where the skip list, is taking more advantages as comparable to normal linked list. That is where, because we are creating a log of n number of layers, so somehow we are doing a searching thing as a time complexity in big O of log of n, right? So here the same thing I have written in my presentation also. Maybe I'll attach this presentation. You can go and read at least once. So we always work right in top linked list. Here suppose I am taking an example of 2-layer linked list L0 and L1, but I showed you the 4-layer linked list L0, L1, L2, L3 and L4. So the rule is you need to work right in top linked list until going right would go too far, by saying that if you are encountering some value which is having a value greater than the value that you are looking for, you need to walk down to the bottom list. And then you need to start working right in the L0 until the element is found. So here if the previous image which I have shown you, for that consider the key as 8, you want to search, you start from L3 layer, you get a encounter value as key which is less than 13, so you will move towards bottom layer which is L2. Now you again check at the L2, the value is 2 which is less than the key, so you will move forward. So if the value is less than the key that you're looking for, moving forward is the right way. If you're getting a key which is greater, you need to move to the bottom layer. That is the overall idea behind searching a linked list, which I want to tell you. So similarly here, if you will see, you move to the bottom layer L1, at L1 value is 2, you move forward, you got 10, now key is less than 10, so you move again bottom at L0 layer. So same thing which I have explained, I have just written down so that if in future you want to refer this particular slide or the presentation or the video, you can clearly see and you can clearly able to get that how the searching is happening here and how it is efficient as comparable to the normal linked list that we have seen. So at L0 we start from 2, we go to 8, then we found the key and we can return the value as true. This is how mainly searching will happen in case of a skip list. Now the next important part is that, okay, you already built the skip list. You showed me how we can build that using the randomization thing. Then we have also discussed that how basically searching will happen. But suppose I already have the skip list and I want to add one more node inside that. For example, maybe I want to add 23. So the question you can ask from me that where should I do the insertion? So the simple answer for that question is that insertion will always happen at the lower level, that is at the L0 level. That too in the ascending order only, the fashion which you have seen. It is only beneficial, again, you all know, we already have understood that binary search is applicable only for a sorted data. Here same rule is also applicable because then only that will make sense to going towards the bottom layer or going towards the right? So if suppose I want to do the insertion of 23 node, first of all I will check what's the correct place where should I allocate this 23 at the L0 layer. That I will be able to find out between 22 to 26, right? So again, how you can do that? You can simply search for the position, for example 23. So you can search starting from the upper layer, you're getting 13. It means that the value of 23 should be present at the right side of 13 only, right? In that sense, you will be reaching towards the L0 layer. Always the insertion will happen at the lower layer. And after that, once you will be able to recognize the correct position, that is between 22 and 26, you will try to allocate that particular node. And after that, again, you will try to apply that randomization data structure. You will try to flip a coin and check whether the head is coming or the tail is coming. If the head is coming, you can just try to grow your layers. Otherwise, you can simply skip that. That is the overall idea or the objective behind insertion in case of a skip list. So that is what I have written here as well. So to insert any element into a skip list, what you need to do is that, first of all, you need to search that at which particular portion at the bottom layer, at the L0 layer, this particular skip list or the node can be fit. Always you will need to do the insertion at the very end. After doing the insertion, then you can check the randomization rule again, which is flipping of a coin, head is coming, growing the height, otherwise skip that. That's the simple funda that we need to get here. After that, the next important part is the deletion, right? Okay, so we need to create the skip list. Now suppose 23 we have able to achieve the task that we need to insert it between the value of 22 and 26. Now I want to delete 23. So again the same thing will happen. First of all, you need to search the element. Searching cost will be log of n, as we already have discussed. So now you need to start from the upper layer. Then again you need to search for an element where that element should be present. Once you will be able to get an idea that okay, 23 is present between 22 and 26, you will delete that. And once you delete that, suppose there are upper layers also at L1, L2, L3, you need to delete all the levels. Deletion means complete deletion. It's not like that at L0 you have deleted, but at L1, L2 or L3, the nodes are there still. That's not happening here. So this is the overall modification or the operations behind the skip list, how we can do the searching, how we can do the insertion, and how we can do the deletion. To get a better sense, the reference book that you can get is Introduction to Algorithms by Corman. So here, majorly what we have observed in overall session of skip list, we have seen what's the motivation behind using these randomized data structures, why basically we are using a skip list, what is skip list and why it is required. After that, we have talked about the building part. I have shown you that how we can simply build any skip list if required. And then we have observed how the searching, insertion and deletion operations can happen in a skip list, right? So I hope that this session is pretty much helpful for everyone, specifically for those who are listening this for the very first time, right? I just want to give you the intuition here that why and how this kind of data structures are pretty much important, right? And what is actually the meaning of randomized data structure here, right? So I hope that are making sense to everyone. Yes, if you still have any doubt, do let me know in the comment section. And with this, happy learning to all. Bye-bye everyone. I'll see you all in my next upcoming video.